Chalo, cams on everyone. Let's get this. Wait, actually, before this, now that rotation, we had one or two questions left over. Let's finish off these things. We did this. Then we have a disk here, mass and radius are bullet hits tangential and gets stuck. Again, standard questions. A man of mass m is standing on the edge of the disk and jumps with speed u relative to the plank. Find omega of the disk. There is a disk with two spheres inside and rotates. The spheres go to the corner. Find the new omega. There are some standard models on angular momentum conservation. How do we do this thing? So when the bullet hits tangentially, it gets stuck. Torque about the hinge is zero. Initial angular momentum is mru. Final angular momentum is I omega. I of the disk plus I of the particle. Single step. What about the second thing? When the man jumps from the plank. Now again, remember that word, it is u relative to the plank. That means when the man jumps, this is the top view, everything is at rest. When the man jumps, this whole setup is rotating with omega, and this guy is not jumping with u, he's jumping with u minus r omega. Remember that? The moment he tries to jump, the plank is already going back with r omega, so he's actually jumping with u into r minus omega. L initial is equal to L final. L initial is 0. This will be mr square by 2 omega minus man ka mass, speed of the man into r. Interestingly, you still get the same answer. And what about C? Same stuff. L initial is equal to L final. Initial angular momentum is mr square by 2. Final angular momentum mr square by 2 for the disk, and for the two balls it is mr square plus mr square omega. Clear with this. Let's get this thing. Top view, we have a rod and two balls of mass 2m, m, 2u, u. They'll collide at L by 3, L by 6, E is equal to 0. Find omega final. If you see the masses, right, I gave it in such a way the center of mass still remains the center only for the system. So this would be the center of mass of the system. Even if something would have been different, the whole center of mass would have been shifted. So talk about the center of mass. You can conserve the angular momentum about the center of mass. So after collision, your picture will look like this. This will be stuck here. This will be stuck here. And this whole setup is rotating with omega. So initial angular momentum, L initial is equal to L final, 2 mu L by 6, m2 u L by 3 is equal to moment of inertia of the rod 4m L square by 12 plus 2m L by 6 ka square plus m L by 3 ka square whole omega. Is that clear, everyone? You can treat that whole rod as one system and finish it off. All clear with this? We have a cone like this. The lower radius is smaller. The upper radius is capital R. The height is h. You took a ball of mass m and you projected here with speed u. And then what happened? This thing started going down because of gravity. And interestingly, it didn't come out from the lower surface. Find u minimum so the ball does not come out from the lower surface. So you need to think why it won't come out. As you start going down, your speed will increase because loss in potential is gain in kinetic energy. And if your speed increases, then your uh, if your speed increases, then your centrifugal force increases. So it starts pulling you out. If you start going up, your speed decreases, then centrifugal force becomes less than mg, then you start coming down. So literally, this thing is stuck here. It goes down, then it goes up. It goes down, it goes up. It is stuck between the upper and the lower thing. Find the minimum speed so that the ball does not come from the lower opening. One thing is clear. This is based on conservation. Can I conserve linear momentum? No. Can I conserve energy? Yes. Can I conserve angular momentum? Yes. So how do we do this thing? So your initial state and the final state. So let's say when you come to the lowest position, so here your speed is u. At the lowest position, you will have a speed Vx and Vy. Since you said minimum speed, Vy will be 0. If u is not a minimum, then Vy will not be 0. So that guy is 0. Conservation of angular momentum about the central axis. There is no torque about the central axis. Mu capital R is equal to mvx r small r. Conservation of energy. Half mu square plus mgh is equal to half mvy square. Vx square. There are two equations to unknowns. You'll get the answer. Clear with this? You can take that Vx here and substitute. You'll get u ka value from there. Got it? This point is fixed. This is k. Spring is in natural length. L. At the edge of this, we have a mass m, which is projected with speed u at an angle theta. This is the top view. This whole setup is on a smooth floor. So there's no gravity. So basically on your floor, one side of the spring is fixed and the other side you kept a mass m and you kicked it. Find max elongation. Or compression. Just get me the equation sufficient. Let me ask you this question. In this question, can I conserve linear momentum? Can I conserve work? Can I conserve angular momentum? Which one can I do? Let's ask me, can I conserve linear momentum? Yes or no? Why not? Why can't you conserve linear momentum? क्या था reason? Your feeling? There's enough external force. Where? Because you fix this point. Because that point is fixed, there's an external force. You can't conserve linear momentum. So since there's an external force, can you conserve energy? Since there's an external force, can you conserve energy? Even though there's an external force, that point is not moving. So displacement is 0. So work done is 0. So you can conserve energy. So then you're done. There's nothing there. You just need to draw the final picture. How will the final picture look like? The final picture, the velocity will be perpendicular to the spring, and this will be L plus x. Why it is perpendicular? If there is a velocity along the spring, that means the spring will continue to stretch. Conservation of angular momentum, mu sine theta L is equal to mv L plus x. Conservation of energy, half mu square is equal to half kx square plus mv L plus x. You solve this, you get a quadratic. One is the maximum compression, one is the maximum elongation. Numbers are given, you could have done these things faster, but that's the process there. Is that clear, everyone? We have a disk here, capital M, radius R. This is A, this is B. AB is the diameter. Others, do keep your cams on. And we have a person here, mass small m. So this person walks along the circumference from A to B. Now, when he started walking from A to B, the disk will not keep quiet. The disk will rotate in the opposite direction. Find the angle rotated by the disk. The man is standing on the edge of the disk and he walks on the circumference from A to B. Meaning, if I have to show you the picture now, it would look kind of like this. Initially, AB ka line was like this. After some time, AB line was like this. So this man didn't actually walk 180 degrees. So this guy was standing here, then he reaches here. So in this scenario, the disk must have rotated theta and this guy must have rotated pi minus theta. So I'm asking you find theta. Nee, Vihan. This thing, if you look at it, it kind of looks like the man working on a Planck problem. It looks like that. The answer is not same. Be careful. So when he walks on the circumference, the disk will rotate in the opposite direction. Try. I'll give you a minute. It's a good one. Right now, yeah. Nee, Advait. Let's see. So what is happening here? The angular momentum is what? I into torque on the system is dl by dt. Right? Or let me do it like this. L bar will be I of the disk, omega of the disk, plus I of the man and omega of the man. Since the whole system is at rest, this is 0. This is omega d theta disk plus I man d theta man. Since initial angular momentum is at rest, so I of the disk will be mr square by 2. Theta of the disk is theta k cap. I of the man is small mr square. This thing will be pi minus theta minus k cap. So you get theta is equal to m pi by m plus n by 2. So you can actually remember the result like this. Theta will be I of the man, the whatever is the total angle rotated by I of the man plus I of the disk. Remember उसका formula क्या था? ml by m plus n. In place of m, put moment of inertia. Getting it? Don't put masses. We have a rod here, mass m length L. Top view. We have a mass m going with speed u. It hits here at a distance of L by 4. E is equal to half. Find m by small m if ball comes to rest after collision. This is a good one. Right, I'll give a minute more. These kind of problems, basically, there are three steps: conservation of linear momentum, conservation of angular momentum, coefficient of restitution. All collision problems, there is only two concepts technically: momentum and restitution. Since there is a rotation involved, there is also an angular momentum. So let's see. Step one, draw the final picture. The ball has come to rest, so that is one thing. This guy is going with V and this setup is rotating with omega. Conservation of momentum, mu, must be equal to mv. Done. That is one step. Next thing, quotient restitution. Now be careful. When you write quotient restitution, you should take the velocities of the points of collision. So this is v plus omega L by 4. So when you write E is equal to V2 bar minus V1 bar, V2 is V plus omega L by 4 minus 0 by U, that is U minus 0. Are you clear with this? The V2 and V1 are not the velocities of the bodies. Those are the velocities of the points of collision. This is your equation 2. Then conservation of angular momentum. You can take any point. I will take the point of collision. So we have the ball, L initial, L final, the ball, and the rod. Initially, ball is 0 because it is passing through A. Finally, ball is 0. It is rest. Rod is 0. Finally, the rod will be mvl by 4, direction minus k cap, plus ml square by 12 omega k cap. So from there, you'll get a v is equal to omega l by 3. That's your equation 3. 1, 2, 3 solve, you'll get the answer. In this rod and the ball collisions, this is the process you follow: linear momentum, restitution, and angular momentum. Angular momentum, preferably you take the point of collision, that saves you time. Clear with this? Let's say we have a rod of mass m, length L, traveling with speed v. There is one more rod here, same mass, length L at rest. This thing comes here with speed v, hits and gets stuck. After getting stuck, it becomes an L-shaped rod. And this whole setup is rotating with omega. Find omega. So we have a rod of mass m length L going with V, hits a rod at the end and sticks. So it becomes an L-shaped rod now. Find the omega of the system. V by 2. Well, you can't conserve energy, huh? Because E is 0. I'll give you a minute more. 3U by 4L. 3U by 2L. We have two different answers. Let's see. So here there is one point which will go undeviated, the center of mass. So when it is about to collide, the center of mass will be somewhere here. This distance will be L by 4. So center of mass will go with the velocity of V by 2. So this is going in a straight line, and about this point the whole thing is rotating. And if you try to draw the picture after some time, the picture will become like this. But the center of mass will be somewhere here. So center of mass does not care. It will just keep going in a straight line independent of everything. So your center of mass is one good point to calculate moment of inertia. But the problem here, we need to find the moment of inertia, meaning angular momentum. So this is your center of mass. What is that distance? This is L by 2, L by 2. That will be L by 2 root 2 to L by root 2. So this distance is L by 2 root 2. And this distance is L by 2 root 2. So initial angular momentum, M, V, L by 4. Only one rod is moving. Here, angular momentum of the system will be I center of mass omega. What is I center of mass? ml square by 12 plus m into L by 2 root 2 cos square into 2 times, because there are two rods. You're getting it? I'm finding angular momentum about center of mass. The translation component will be 0 because VCOM will pass through the center of mass. Technically, you could have taken angular momentum about any point. But center of mass looks nice, so just took it up. How much will this be? That will be ml square by 6. That would be ml square by 8. So 2 goes off. That is 6 and 4. So 10 by 24, 5 by 12, 3. I think 3v by 5l. Play with this. That's it, one step. You can conserve angular momentum about the center of mass and you'll get it. Check the calculations. Clear? If you want ICOM, you can't directly do it. You have to take center of mass, you have to use parallaxes theorem. That's a bit about angular momentum. And you can keep going on, but I think we covered the main important models. Let's get this thing, SHM. We have two balls, top view circular track of radius r. Both the balls have same mass, but they're going with u and 3u. Find the time period. SHM, if you remember, we already covered, few models in different chapters. What kind of motion is this? This is not SHM, this is periodic motion. If you remember, even before SHM comes, there are two types of motions, periodic and oscillatory motion, and then SHM. If that had been u and 2u, you'll get a different answer. U and 3, you'll get something else. The answers will change. But let's get this thing. Two identical balls, E is equal to 1. It's a perfectly elastic collision. It's a circular track. Find the time period of the system. Again, what is the definition of time period? The motion should repeat itself. The particle should come to the same position with the same velocities in the same way. Yeah, let's see. Now, the thing is, since the balls are identical, they'll exchange velocities after every collision. Now we can get the time period here, t, which will be 2 pi r by 4u. This is the time interval between two collisions. The relative velocity is 4u and the distance is 2 pi r. Now for simplicity, what I will do, I'll call them A and B. Since it is going with u and 3u, the first collision will happen here. Right, and A will be here and B will be here. Now A will go with 3u and B will go with u. Second collision will happen here. A will be here. After collision, it will go with u and B will go with 3u. Then the third collision will happen here. B will come back here with u and A will be back with 3u. Then the fourth collision will happen here. And then they'll repeat. Therefore, the time period will be 4 times 2 pi r by 4u. Is that clear, everyone? It takes 4 collisions for the balls to come back to the same position in the same way. That is the meaning of a time period, isn't it? The motion should repeat itself. Clear with that? Now, same question, can you do this if that was not 3u, but if it is 2u? Something changes. Neither much. If it is u and 2u, then what happens? I think this we did in the class. You guys are not revising the notes as you should revise the notes. You should go through the notes once or twice, multiple times before your mains exam. You learn a lot. You'll see a lot of different models. If you're struggling to score in physics at least 70, 80 marks, you should just stick to the class notes and PYQs. Again, if the papers are hard, then it's a different story though. If I'm talking about proper mains level papers. What are the catch here? Same story. The time taken between two collisions is 2 pi r by 3u. But here, look at the problem here. Something happens. Let's call it A and B. So the first collision will occur somewhere here, 120 degrees. So A will go back with 2u. B will go back with u. The second collision will happen here. A will go back with u and B will go back with 2u. This time when they collide, the third collision here, unfortunately, they don't come to the same place. A comes here and B comes here. Now, it might look like they come to the same place because they're identical, but if you see, if you mark them as A and B, the positions are reversed. So after every 3 collisions, they come to the same place, but positions reversed. So this is not a time period. When you say time period, they should come to the same place in the same way. So after 3 collisions, they come to same position with same place with positions reversed. So A goes to B ka place and B goes to A ka place. That means this motion will repeat after 6 collisions. Therefore, time period is 6 collisions. So you need 3 more collisions to get back to the same place, 6 into t. That is 4 pi r by 4 pi r by u. Clear with this? That is a catch. In the previous case, it didn't happen. Huh? They came back to the same place after the 4 collisions. But here, after every 3 collisions, they come to the same place with the positions exchanged. So you have to do 3 more collisions. Right, Jainil. Right, Devansh. Yeah. Same question. Let me ask you one more. Let's say E is not equal to 1. E is E only. Okay? And these masses are also not same. Let's say this mass is M and this mass is 2M. Velocities are U and 3U. Find the time interval between 100th and the 101st collision. So since E is not equal to 1, they will collide and they'll slow down, slow down, slow down. Time interval between 100th and 101st collision. But this is not a periodic motion. More of a collisions ka question. So how do you handle this? Hmm. Now, what most people don't realize, right? After collision, let the velocities be v2 and v1, right? We actually don't care about v2 and v1. What we care is a relative velocity. So for that, you need not do anything. E is equal to v2 minus v1 by u1 minus u2. This is v relative after collision. So you directly get v relative. So the thing is, you don't want v2, you don't want v1, you want v2 minus v1. This is v relative before collision. Again, head on. That means the v relative after collision will be e times u relative. So after every collision, your relative velocity becomes e times, independent of the mass. Let the masses be anything. Getting it? So this will be e times relative is 3u. So velocity after 100th collision will be e power 100, 3u. Therefore, the time interval will be 2 pi r by v relative. Easy. So the coefficient restitution gives you the relation between the relative velocities. You don't want v1, you don't want v2. What you want is v2 minus v1. And let them collide however they want. It doesn't matter. The masses can be anything. So the relative velocity always becomes e times. After 100 collisions, relative velocity becomes e power 100. So that's the time between the two collisions. Clear with this? Now, since I asked you this, I remembered something else. Let me ask you that also, even that is not SHM. Let's say I have 3 boxes. Identical boxes. In one case, you projected a ball with speed u, it goes here and comes back like this. In another case, you projected the ball from this corner it comes back like this. Another ball you projected like this, it hits here and comes back like this. So they hit the wall and they come back to this is the top view, there's no gravity. Right, so this time interval is t1, time t2, time t3. So this is the time taken to come back to so balls are projected from the lower wall and they should hit the upper wall and come back to this time. So time taken, I'll do one thing, but let's simply call it A and B. The time taken to go from A to B. Arrange them in the descending order. The pictures are up to scale. 3 identical boxes, same width. One ball is projected with more angle, steep angle, and E is equal to 1 for all collisions. Actually, it doesn't matter even if it is just E also. In which of these cases will take more time? Aditya. All are projected with same speed. Nee, wait, I need to give you a little more data actually. I missed out on something. This is theta. This is theta. The angles of this thing is same. You need that. Second picture. Or should I draw this? I drew something wrong here. Okay, let's compare T1, T3. I missed on something. Okay, we can compare these two. Previous one I could have compared actually, no? That angle was more steeper. Okay, we'll keep it. We'll say these two are equal. This is a smaller angle. What can you say from this? Now see, end of the day, what you're interested, if that is theta, this component is u cos theta. This component is also u cos theta. Right? During a collision, what changes? When you hit the ceiling, only the vertical component will reverse. When you hit the side wall, only the horizontal velocity will change. So when you're hitting the wall, the side wall, the vertical component won't change. So T1 must be equal to T3. And you can calculate that value also, which is 2L by u cos theta. Think about it. Because you're covering vertical distance, you are only interested in the vertical velocity. The horizontal component is useless. Is that clear, everyone? In the second case, because this is more steeper, this angle, this component must be greater. So the time T2, which is 2L by that uy is greater than u cos theta. So this must be smaller. So T2 must be less than T1 equal to T3. Clear with this? End of the day, if this theta and this theta is same, the vertical component is always u cos theta. You go up with u cos theta, you come down with u cos theta. Horizontally, what happens, it doesn't matter. So that will only create the horizontal displacement. Is that clear, everyone? Let's get these two. Yeah, that's a bit of a collision. Hope you remember these questions. This question can come in waves, it can come in SHM, it can come in alternating current. Find the amplitude. That's the question they'll ask you. There, x is equal to 20 cos square pi by 3t pi plus 6. Find amplitude, the mean position, maximum speed, phase angle, maximum acceleration, time to reach the mean position. At t is equal to 0, plot potential energy, kinetic energy, velocity, acceleration. I want the values actually. Find the potential energy, kinetic energy, velocity, and acceleration at t is equal to 0. The second is a very important question, a standard model. Find the time when they meet for the second time and find the maximum distance between them. You can say that, Vihan. Yeah, a question when I wanted to ask something, I forgot. Something I mixed it up. Recently, I was asking your juniors that question. I'll see, I'll remember sometime later, I'll ask again. Let's get these two. Try. I'll give you 3-4 minutes. Even if you can get the main equations and leave it, that is okay. But both are important. Standard models, these are. If theta is not same, then you can't say. It actually depends on the theta only. I think now a question where a picture is like this, I guess. One goes and comes like this. One hits like this. I think the other one hits like this, I guess. ऐसा कुछ था. I made sure the u cos theta is same for all. In that case, all three were equal. Your juniors, na, they all literally calculated the length of the path. Whichever is bigger, they thought that was time more. They all got slotted. It was fun. Once I said u cos theta is same, they're looking at me like, okay. You guys got it fast. They took time. I hope you remember how to do that. 20 is not the amplitude. What is your general equation? In case you forgot, your general equation is x minus x mean a sine omega t plus 5. There, this is your general equation for SHM. You have to convert this into this form, and then your job's done. I asked a lot of questions, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. Let's see. So how do we write in this form? Cos square is 1 plus cos 2 theta. So this is x is equal to 20, 1 plus cos 2 theta, which is cos 2 pi by 3t plus pi by 3. by 2. That would be x minus 10 is equal to 10. That will be sine 90 plus theta. So that will be 2 pi by 3t. 90 plus 60, 150. 5 pi by 6. This is your x mean, which is 10. This is your amplitude. This is your omega. This is your phase angle. You want Vmax, a omega. You want maximum acceleration, a omega square. Right? You want potential energy. The potential energy ka formula, we will get there. What else you want? Time to reach mean position. That means, first of all, let's see where is this guy in the first place. If you actually look at this motion, this guy is going from x is equal to 10. That's your mean position. This is oscillating between x is equal to 0 to x is equal to 20. You're getting it? These are the extreme positions. Be careful. Every time x is equal to 0 is not the mean position. So this particle is oscillating between 0 to 20. T0, where are you? If you put T0 here, then your x ka value will be 20 cos square 30. Cos 30 is how much? Root 3 by 2. That's 3 by 4. 425, 15. Means at t is equal to 0, you are at x is equal to 15. So that means this distance is a by 2. Actually, you can see 5 pi by 6 is that only, na? 5 pi by 6 means the particle has gone here and it is here. Make sense? So this particle is at x is equal to 15, which is a by 2, and you're traveling towards the mean position. Anyone remembers what is the time interval from here to here? Kitna tha? I told you I have to do that in case you forgot. Half. So sine theta is half. Means it is 30 degrees. If 360 takes time t, then 30 will take how much time? T by 12. In case you forgot about that, do remember this results. X is equal to 0. X is equal to a by 2, a by root 2, root 3 a by 2. Here to here, this will take t by 12. Easy way to remember, sine theta half is 30 degrees. 360 will take time t. This will take how much time? Here to here, it is t by 8. Here to here is t by 6. Here to here is t by 4. And then automatically from here to here, this will be t by 12. This will be t by 6. And this will be t by 8. Remember those results, helps you, saves your time. And then I got x is equal to 15. So what else you need? You want kinetic energy? Differentiate it. That is the fastest way. Dx by dt, that will give you the velocity. Kinetic energy is half mv square. Right? Or you can use that half m omega square a square. That is also fine. You're asking kinetic energy at t is equal to 0. Okay, then I think I can do this. V is equal to omega into root over a square minus x square. Yeah, use that. That is better. Kinetic energy is half mv square. I need to give you the mass actually. Right? And what is potential energy? Potential energy will be half m omega square x square. Velocity, acceleration is equal to omega square x. You get everything you want. Clear with this? What about the second one? Find the time when the two particles meet and find the maximum distance between them. Do you guys remember the formula for that maximum distance? That's a straightforward formula. You should definitely mug it up. You won't have time to derive in the exam. The max distance ka formula is given by 2a sine phi by 2, where phi is the difference in the phase angle, phi 1 minus phi 2. In this scenario, it is 2 pi by 3 minus pi by 3. Pi by 3. 20, that will be sine 30. 10. Don't forget that. How do you find the time though? Find the time when they meet for the second time. So if they're meeting, x1 is equal to x2. Sine omega t plus pi by 3 is equal to sine omega t plus 2 pi by 3. If sine theta is equal to sine alpha, you know what is the formula there? Omega t plus pi by 3 n pi plus minus 1 whole power n omega 2 plus 2 pi by 3. If I put n is equal to 0, time will cancel. So n is equal to 0 is useless. If you put n is equal to 1, you will get some time. This is the first time they meet. N is equal to 2, again time will cancel. N is equal to 3 will give you the second time. So put n is equal to 3. That is the second time they meet. So these two particles will keep meeting infinite times. Clear with this? In case you forgot all this stuff, no problem. Go back, revise your notes. It will take a day or two. You'll be back on track. Forgetting is fine, but what you do after that matters more. Let's get these two. X is equal to 10 sine omega t, 10 root 2 sine omega t plus 5 by 4. Find amplitude. U is x square minus 14x plus 50. Total energy is 100, mass is 2 kg. Ke max, amplitude, x mean, time period, oscillation energy, minimum energy. Plot Vx graph, Ax graph, kinetic energy, potential energy, total energy versus X graph in SHM. Let's finish it off. Today there'll be no break. I will leave you a little early also. My eyes are burning for some reason when I'm looking at the screen. 10 root 5. सही है. The same question 4A, na? If I could have given current I and I could have asked you I RMS, isn't it? That would become an AC question. So process is the same. I think there is so much pollution outside, I guess. I was out for some time. I don't know what happened to my eyes. It is not because of the screen. I need to get an air purifier. Yeah. How much is that AQI? It's hopeless. Mhm. My area it is 204. Hopeless it is. Now I understand why Delhi people get situated even more hopeless. Yeah, but for some reason, the entire South India is like this. Entire India is like this. I think Pakistan has better AQI, I guess. Yeah, they don't have AQI machines only. No, they do have one somewhere in Karachi. China is also polluted. Even Europe is not looking that great. There it's all, yeah, but still sub 100. Interesting. What is the answer for this? Ke max is 99. So let's see the amplitude part. I hope you guys remember phasors. Quite an important concept. We use it in at least 3 places: SHM, waves, and alternating current. How to use phasors? We treat the amplitude as a vector ka magnitude and the phase angle is the angle. 10 root 2 and that's 45. Then You resolve them into vectors. This will become 20, and this will become 10, and this will become 10 root 5, and this is your alpha. So you can replace this entire function with 10 root 5 sine omega t plus alpha. If it is an alternating current and they ask you RMS value, then 10 root 5 by root 2. I peak by root 2 is your RMS value. What is this? Force is equal to minus du by dx. That will be minus 2x minus 14 is equal to 0. That mass is 2 kg, so we get acceleration is equal to minus of x minus 7. You can compare this with a is equal to minus omega square x minus x mean. There, so x mean is 7, omega is 1. Total energy is 100. Okay, x mean is 7. So what does u mean? U mean will be 7 square, 49, 50. That is 1 joule. U mean is 1 joule. Huh? So if you guys remember, this was the formula for total energy. Total energy will be the energy of oscillation, which is half m omega square a square plus u mean. याद है? This component is called, this is called oscillation energy. Total energy of an SHM is not same as oscillation energy of SHM. In case you forgot, you should definitely check out the SHM thing. That was a very good discussion. And they do ask, even at advanced May, you get pretty good questions on that. People do goof up. Where did I do that? Here, we wrote the statement. Oscillation energy, total energy, and oscillation energy need not be equal. The graphs also will change. So this was the formula. See, the potential energy is half m omega square u mean. Total energy will be half m omega square a square plus u mean. So oscillation energy is completely different from the total energy. So the page 38 in SHM should check it out. So that's your oscillation energy. Total energy is 100. Half mass is 2, omega is 1, amplitude square, and u mean is 1. So we get amplitude is equal to root 99. Interesting. I should have given 50 joules, I guess. Then you would have got 7. No, number would have been good. Okay. There, if that was 50, this would be 50. This is oscillation energy. This is 1 joule. This is 50 joules. Then you get half m omega square a square is equal to 49. So a is equal to 7. I got amplitude also. I'll get time period also, 2 pi by omega. I got oscillation energy also. I got u minimum is 1 joule, u mean. There I got everything. All clear with this? Again, a pretty good question there. What is the maximum kinetic energy? 99, isn't it? 49. I gave 50 total. What about the graphs? Anyone remember the graphs? Vx graph, Ax graph. The graphs are important. Try, I'll give you a minute in case you didn't do it. Can you draw all these 5 graphs? Vx graph, velocity versus x graph, A versus x graph, kinetic energy, potential energy, total energy versus x graph. You can even play with time, but okay. Assume u mean is 0. If they don't mention anything, look at the graphs. Generally, u mean is 0. What is your Vx graph? If you remember that formula, V is equal to omega root over a square minus x square. This will be V square, a square omega square by x square by a square is equal to 1. This is an ellipse. A Vx graph is an ellipse where this is a omega and this is a. A is equal to minus omega square x. It's a straight line passing through the origin with a negative slope. Tan theta is minus omega square. Kinetic energy is half mv square, that is half m omega square a square minus x square. Hope you remember this. This is the standard one. The kinetic energy graph, meaning it's easy to remember this way. At the extreme positions, kinetic energy must be zero. It's an inverted parabola. At the extreme positions, potential energy is maximum. This is a upward parabola. The total energy will never change. So that will just graze like this constant. Remember the graphs? Uh, let's get these things. Time taken for the particle to go from minus root 3 a by 2 to a by root 2. There are two possibilities. You can go directly or you can go back and go this way, isn't it? Get the time for both of them. These are another type of questions. They will give you two positions. They'll ask you what's the time taken to go from here to there. Find the time taken to go from minus root 3 a by 2 to a by root 2. One directly, one reverse, and then back. They can even ask you this kind of questions. Find the displacement in so and so time. Displacement will be average velocity. That will be displacement in time. So questions would be different. We'll see. I told you the values if you remember. To go from root 3 by 2 to here, t by 6, this is t by 8, this is t by 12, t by 4, t by 8. So you can just add them up. You should know that values for what is the time and time taken from one point to another point. Do remember them, saves you time in the exam. Let's get these two. This is a top view. There are two springs connected to the block. One spring is pushing a sine omega t, another spring is pushing sine omega t plus 5. Find the condition if the block moves in a straight line, block moves in an ellipse, block moves in a circle. If you remember in SHM, I taught you something called Lissajous figures. It's not there in the theory. It's just a thing I just explained you. I don't know whether you remember that, but you remember the story that I told you? In a lab, we are supposed to make this two ellipses like this. This was the experiment. I made a shape like this. याद है I told you this? ये सब बकवास stories याद रहेगा. No, let's get this thing. then I told you that story. Then I told you the shapes which formed are called Lissajous figures. ये SHM में ना ये but different angles and amplitudes you get shapes like this. And for the offline people, I give a printout also of this. This is the same question. Like, see, If both the phase angles are 0, you get a straight line. If the phase angle is 90 and A is not equal to B, then you get an ellipse. If phase angle is 90 and A is equal to B, you get a circle. So check कर लेना एक बार ये this thing in case you forgot. So for a line, the phase angle must be 0. For an ellipse, phase angle must be 90 and A is not equal to B. For a circle, phase angle must be 90 and A is equal to B. In our portion, we have only this much. You don't get that other shapes. The List-Jobs-Vegas thing is not there in our portion. Get the B part. B is a good question. X is equal to A sine omega t. Find the average speed in 2t by 3. This is simply, equation of a, you can just eliminate time and you'll get these equations. This is a good one. Find the average speed in 2t by 3. Be careful. Average speed is distance by time. Don't take displacement. If you substitute 2t by 3, you will get displacement. You don't get time. So in 2t by 3, where do you exist actually? A sine omega t 4 pi by 3. That will be minus root 3a by 2. That means if you actually draw the particle ka path, x is equal to 0, x is equal to a, you reach somewhere here. Now 2t by 3 is definitely greater than t by 2, means you went front and then you came back till here, isn't it? देखो ना, you can actually calculate. This is t is 0, this is t by 4, this is t by 2, and this is 2t by 3. So what is the average speed? Average speed is the total distance by time. What is the total distance? You traveled a, then you traveled a back, and then you traveled root 3a by 2 by total time 2t by 3. Easy? So just be careful there. People, what they do, they put root 3a by 2 by time. That will give you average velocity. Average speed, you have to get the total distance. So you literally have to draw the path. Got this? Let's get these questions. We have a block M. There is a spring here, K1, K2. One side is a rubber band, one side is a spring. Find the time period of oscillations. 3 springs, time period. 2 springs with a distance between them. Spring and a block and a wall. E is equal to 1. Find the time period of oscillations. Let's finish off. Sixth one is the last question. See, people become so happy actually. I hope you know what is the difference between a rubber band and a spring. A rubber band can pull but can't push. Spring can pull and push. Let's see, 1 more minute. So for mains, right, in case you're feeling the class notes is becoming too heavy to do, then you have your revision notes. You should do this thing at least. So people are, there are some people who are like, should we make a formula sheet? I'm making a formula sheet for you right now. Physics में what formula sheet will you make? क्या होगा formula sheet में? Time period is 2 pi root m by k. Done. What else will you have? You need to see different models. What about this guy? See, when you're oscillating, there are two things here. When you're on the left-hand side, this spring will push. The rubber band also will pull. So the time period will be 2 pi root over m by k1 plus k2. But when you go to the other side, the rubber band becomes loose. So there will be only one force, k1x. So the time period will be 2 pi root over m by k1. Since it is doing half of that and half of this, the answer will be t1 by 2 plus t2 by 2. Is that clear, everyone? So left half of the oscillation, it will behave, there are two springs. Right half of the oscillation, it will behave, there is only k1. What about this here? All the three springs are in series. So parallel, 2 pi root over m by k1 plus k2 plus k3. How do you know they're in parallel? When I displace this by x, all have same compression and elongation. If the springs have same compression or elongation, they're in parallel. If they have same spring force, then they're in series. When I push by x, do they have same force? No. They have k1x, k2x, k3x. Forces are different, but they have same compression or elongation. What about this guy? When you go to the left side, the time period will be 2 pi m by k1, half of it. Then you're coming through the block, so d by v plus d by v. That will be 2 times because you're going from front and back, and this will be pi into root over m by k2. Clear with this? What about this guy? From here to here, the time taken is t by 4, and from here to here, a by 2, the time taken is t by 12. So therefore, the time period will be t by 4 plus t by 12, 2 times. Easy. So when you hit the wall and you bounce back, it feels like that. Clear with this? Question is not over, boss. I said sixth question, na? Abhi bhi hai. Let's go. Sixth question is not over. और कितना है इसमें? HGI तक है. Now you're feeling you're trapped, na? Chalo, let's finish all this page. I will leave you. People are putting their pen down, cap tight, sub relax हो रहा है suddenly. Let's finish all this. This is a good one. I hope you remember this formula. I taught you this in NLM में कहीं पे दिया था ये. Equivalent, K equivalent. You're also exhausted for some reason today. Or maybe my eyes are burning, so I'm seeing things, I guess. Or all of you are very fresh and you're ready for like another half an hour. Some people are like, they gave up, like, karo jo karna hai. Chalo, let's finish it off. 1 month for the exam, 1 month, 1 week, 5 weeks left. Keep giving tests, make sure to resolve them properly. Again, I'm telling you, repetition is the key. Don't try to do multiple different things. Mains we need to push 180 plus score, repetition. So what is the answer for this guy? First, you need to figure out the tension here. Let the tension in the block be T, then this guy will be 2T. Then T square by K equivalent will be 2T whole square by K. K equivalent will be K by 4. If this is tension, this is tension, this is 2 times tension. Same story, T square by K equivalent will be T square by K2 plus 4T square by K1. The 1 by K equivalent will be 1 by K2 plus 4 by K1. What about this guy? Whenever you cut a spring, the spring constant becomes 4K. Since you get all of them in parallel, K equivalent will be 16K. So T2 will be 2 pi root over M by 16K. And T1 will be 2 pi root over M by K. There you can divide them. Sure with this thing? SHM at a mains level, right? Most of the time they play with either that things or the spring block systems, angular SHM, and then we have torsional pendulum. These are the 4 cases. Advanced level, you can really play a lot, right? We will still see some models, but pure mains level, they'll stick to the springs maximum. Okay, with that, we'll wrap up for the day. We will catch up again on Friday. We'll continue from here. We will, stretch out a bit also for waves also we have. But again, waves do go through the notes and come. There are a lot of formulas to remember. Yeah, stationary waves, right? The properties of stationary waves. In waves, the main important thing is the stationary waves. Doppler effect is not there for mains, right? But maybe we'll still do 1 or 2 problems just in case because, hey, last year they said it is not there, but they asked. And they gave bonus also. That's a different story, but they still asked. Right? So we will do that also. Okay, with that, we'll wrap up for the day. I'll see you guys again on Friday. We're at 8:30 as usual. So any doubts, anything else, please stay back or else you're free to leave. Any doubts in the class notes first you can ask.